Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. Thank you guys so much for coming in. Anyone who might be lurking in chat, hey, thanks for being here. So, we've got a lot of work to do today. I've missed the past, I think, 3 days. I think Saturday, Sunday, and Monday. Saturday and Sunday I missed because my family visited, so I just wasn't able to, I wasn't really able to stream over the weekend just because my family was here. And then Monday I wasn't able to stream just because I had meetings. And again, this afternoon, like at 4 o'clock, I usually try to do a Klima stream. Wasn't able to do it again because I just had a lot of meetings. Tomorrow I unfortunately won't be able to stream again because of just there's meetings, so many meetings that I have to attend. So tomorrow I'm not going to be able to do it. But Thursday and Friday I'll be back. I'm sorry I've been missing so many streams lately. Hey Trash Talk, how are you? So for today, let's go ahead and start by opening up Zernal PP. And let's talk about the schedule for today, Thursday, Friday, Saturday, and so on. I think today, Thursday, Friday, and Saturday is what I'll focus on. So today, which is Tuesday, we will focus on domain coloring, finishing up the chapter, domain coloring. Now, Thursday, what I'm going to do is I'm going to finish working on the iterative function system video number 2. We have the script ready to go. It's just a matter of, audio editing, and then Friday, we might still be working on this. If not, we'll talk about new methods. We're either working on this or this, but if we get both of those guys done, then we're working on new methods for inverses, and eventually moving our way into power iteration, which is ways in which we find eigenvalues and stuff like that. And Saturday, I'm going to do, hopefully, a bit of a longer stream where we focus exclusively on video editing. Actually, I don't know if I'm going to stream this or not, but Saturday is going to be entirely video editing. Again, I'm not sure if this is going to be live or not, but it's something that needs to be done because I'm really shooting to get that video out on Sunday. If not on Sunday, maybe Monday, but I think I can get the entire video edited if I just sit down and I do it. Let's see. I don't really know where to parrot this, but in the sepia night mode of the algorithm archive, some text gets hard to read. Yeah, let me see. Thanks for that. Report. Okay, yeah, of course. I didn't know what you meant. Yeah, let me see. PNG. I'm not sure what text you're talking about there. Let's see. What text is hard to read? I'm sorry, I don't understand. Algorithm archive. Let me see. Sepia. You're saying type to search here is hard to read, I think. I see. Yeah, okay, that's fair. Yeah, feel free to create an issue on that for GitHub. So we are going to be. Actually, is this something that we don't have? Let me look for domain. No, let's look for plotting. This is actually super nice. Do we have a search function in algorithm archive pi? Is that something that we have to add in there? I forgot that we had a search function entirely. But yeah, thanks for mentioning that. If you want to create an issue on the algorithm archive GitHub, let's go here, github.com/ algorithm archivists, algorithm archive. Feel free to create an issue here. And if not, I can do that for you. But yeah, do it here. That way it's on a list of things that we'll attack. I usually look at this pretty much every day. I'm not looking at it today, but I will definitely look at it tomorrow and Thursday and so on. Today I've got to focus on the next chapter. Thanks for bringing that up. Really appreciate that. Okay. But actually, I completely forgot that we had this type to search function. I just completely forgot. So if I'm looking for matrix, that's actually really cool. It brings up all matrix methods, you know? Yeah, I like that. I forgot that existed. So we're in the process of updating the algorithm archive. Yeah, but also like this is incredibly hard to read. I completely see what you're saying now. So if we go to sepia, it's not so bad in sepia, but obviously it's best in white mode. Yeah, okay, thanks for bringing that up because that is something that I hadn't really considered before. Cool, appreciate that. Yeah, just put these images in there as well. Just say, here are some images of it, being hard to read that. And then also say that like some of the text is hard to read as well for the dark mode, because I think that's definitely true as well. Cool. Thanks for that. So let's talk about what we're working on today. Did I open up Zernal PP? I did. Okay. So this is kind of the plan. Hopefully we'll get a new video out on Sunday. I am shooting to get that video out on Sunday. So we'll see how that goes. Wow, that is not how you draw a box. let's try this one again. Sunday here. Yeah, after the last video, I kind of realized that, you know, putting videos out really does, you know, motivate people to come into Twitch and, you know, the algorithm archive and all this kind of stuff. So it's definitely something that, you know, absolutely should be done in the future. So I'll be continuing to do that from now on. Okay, so let's talk about what we're doing today, which is domain coloring. Okay. Very quick introduction for those of you who don't already know. Here's the idea. Let's say we have some function that is f of x equals x squared. If we want to plot this function, typically we have a number line where we have f of x on the y-axis and x on the x-axis, and this allows you to see some sort of, you know, exponential, well, not exponential, some sort of parabola function, right? But let's say x is within the set of complex numbers. Well, if it's within the set of complex numbers, then, you know, this has an imaginary and real component, which means necessarily that the output also has an imaginary and real component, right? And that's kind of hard to plot, right? So the idea with domain coloring is that we draw a box, right? And on, you know, let's say the x-axis here, we put the real, and on the imaginary axis, we put the and on the y-axis, we put the imaginary of x. Here's the real of x. And then the output of these guys is the output is then projected onto the color bar over here, which is typically an HSV. So like, for example, the imaginary of our function of x could be in the saturation, and the real of the function of x could be in the hue, for example, of this three-dimensional color bar. So I'm in the middle of writing this chapter. I really didn't mean to get to it this weekend. I was just distracted this weekend with various things. I probably shouldn't have taken the time off, but I don't know. In some sense, I kind of feel like I needed the time off. But yeah, so I'll be working on this today, writing the new chapter, and that's kind of what we're focused on doing. So as a quick introduction, let's go ahead and cd into projects, Simuleos, domain coloring, ls here. In fact, I'm going to open this up in a new terminal. So we're going to cd into projects, Simuleos, domain coloring, and let me just do mirage out.png. Yep. So this is an example of a domain colored image. Let me just make it big so you guys can see. Yeah, so the idea here is that the color is related to some sort of complex phase. And then we have additional lines that we'll be talking about later in today's episode. So yeah, stay tuned for that if you're interested. But yeah, it makes a lot of really cool and interesting plots. And there are some things that I kind of want to just talk about and talk through with you guys. So yeah, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I will totally address it as soon as I see it in chat. Today might be a bit of a shorter stream. Like, I am trying to stream more frequently, but also I've been kind of realizing that a lot of people aren't particularly interested in the domain coloring here on Twitch, which is kind of weird to me. Like, I don't exactly know why, because it is like a super visual thing. Like, you know, you look at it, it looks cool. But yes, a lot of people on Twitch aren't particularly interested in it. So we'll just see. Like, if it ends up being that no one wants to watch me stream this, I might just work on it on my own, which I've been trying to do for the past few days. I've just been kind of lacking motivation. There was something that T.S. Joss brought up the other day. You know, he said, like, you know, we were talking about about whether I should stream video editing or not. And the truth is, there's just certain stuff that I just don't feel like should be done on stream. And writing, for example, is one of those things. I used to say that, you know, code review is another one of those things. You know, algorithm archive, or sorry, video editing is another one of those things that I just find I just don't want to do on stream. It's one of those grunt work type of things that I just don't think people can be motivated to watch, you know? So yeah, feel free to let me know what you think about that. I might just end up writing this on my own, and we can go from there. Cool. So let me move this up into the upper left-hand corner, and then we'll go from there. Okay, we'll move that here. And then we'll move this down. But also, you know, it could just be I'm tired today, you know, another thing. Okay, move this in here. And we're going to move this down here so no one has to see it. Well, 1 second. Something like that should do. Okay, cool. So let's go ahead and cd into projects, algorithm archive, and same thing over here. CD projects, algorithm archive, gitbook serve, and we'll just go ahead and start writing the chapter. So let's go to VI. Actually, we're going to be doing a lot of stuff really quickly here because I got to a stopping point, or I got to a tough spot in writing the chapter last time. And so let's go ahead and start working on that when we get into it. So let's go into VI, CD content, CD contents, domain coloring. Let's go to VI domain coloring.md. Okay, so where did we get to? Let's go ahead and read that over here. There. Okay, put this down there. And let's see, so we were at domain coloring here. So how far did we get? So we got the first two images done. Then we started talking about, don't know what happened there. So let's try to fix that. It looks like it is broken. Where? Where is it broken? We can generate the following image. It's broken here. Oh, I see what I did wrong. Let's go here, change that. Simurakon, thank you so much for following, really appreciate it. And let's see, so I wrote something here that doesn't actually make any sense. So I said, as an example, let's again look at the function f of z is equal to z squared. But in this case, z is within math BBC, so it's within complex numbers. If we're using a black and white color scheme, where black represents theta and white represents r, we can generate the following image. This won't work. We have to use an RGB color scheme. So if we use a red, green, blue, let's see, an RGB color scheme, let's see, where we'll say red represents theta. Maybe change that there. And blue represents R. Thanks for streaming, especially about algorithms. Yeah, thanks for coming by. Mr. Hour, thank you so much for following. Really appreciate it. Yeah, so what we're working on today is an algorithm for, I guess maybe it's not so much of an algorithm. It is going in the algorithm archive, but it's a plotting technique to show complex outputs. So this is eventually going to bleed in or build into our chapter on Fourier transforms, which we already have, but is in massive need of reform. So that's why I'm working on this right now. Okay, so what am I saying here? So if we use an RGB color scheme, where red represents theta and blue represents R, we can generate the following image. So let's just create this script that does this thing that I'm trying to do right here. So I'm trying to take the script that we have to generate this image up here in the upper left-hand corner and change it so instead of using an HSV color scheme, we use an RGB color scheme. That could be a bit weird, so let's just see what we do. I'm going to, I guess, open up a few more terminals. This is Simuleo, so you know, it's what we do here. Open up terminals. Why not? Move up here. And move this down here. 1 second. Why is everything just subtly off? We're off by like 1 pixel for some reason. And it's kind of driving me nuts. Okay. And let me just open up a new terminal down here as well. So these new terminals that I'm opening up are meant to be for the domain coloring running and stuff like that. That way I have one for the algorithm archive and one for domain coloring. So we're going to CD into projects, algorithm archive, contents, domain coloring, CD code, and then new plot, ls, and let's go over here. CD projects, algorithm archive, contents, domain coloring, code, and then new plot over here. Okay, so let's see, what do we have here? I've got a file, and I don't know what I'm actually plotting here, so let's just do mirage out.png. What does this look like? Okay, so this was my attempt yesterday. So I did work on this over the weekend, and I did work on this yesterday, and didn't quite get what I was hoping to see. So this is kind of why I'm live streaming it, because I thought there was some cool visual output that we could do here, and I thought it'd be interesting just to talk about. So this is the same thing as this. Let me explain. So these two images look remarkably different. So let me just move this so it's big again, you know, and then let me move this other image so it's also big. And I'll talk to you about things that I like about this new image and things that need to be fixed. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. So at first glance, these don't look too similar, right? Like, Clearly, they're different. You know, we don't have any of these black lines going along this one. There is something I really like about this. If you look at the phase here, it's clearly going from blue to red, and then again from blue to red, right? If you look over here, we have a red here and a red here, which means, again, red and red, it means we're going through a full cycle at the same rate as we're going through here. This is a 4 pi phase winding in here. This is also 4 pi phase winding. So one reason you might want to use an RGB color scheme, for example, instead of an HSV color scheme, to look at, you know, phases and stuff like that, is because in an RGB color scheme, it's very easy to find this point of singularity where, you know, it's kind of, the phase is undefined. And there are certain systems like vortex tracking, which is what I did my PhD on, where this is incredibly useful, you know? But hey, you know, sometimes, oh, what? Wait, I think I missed something. Oh, no, I think I got it. Okay, sorry, I thought I missed a notification. So sometimes that's incredibly useful. So I'm going to be working with this image so that we kind of get an image that I expected to see when we do RGB. And then I've got to figure out what this color bar is doing on the side. So it's really glitchy. Like, there's a bunch of weird things I have to work on. So I'm going to leave this up in the upper left-hand corner for reference, and we'll just kind of work on our stuff. Cool. Looks like we're getting somewhere. By the way, I don't know how many people are in chat. Over the weekend, I mean, this is a side story. It's not related to stream at all. So over the weekend, I started looking at Pokemon again. I hadn't played Pokemon in ages. Like, literally, a super long time since I played Pokemon. Particularly because after Generation 4, I didn't like Generation 4. Nor did I like Generation 5. So, you know, I didn't really play it so much. Like, I played Generation 1. Generation 2 was my favorite. And then Generation 4, 3 was okay. 4 was like, I don't really like this generation anymore. And then 5 had a great story, but I was like, no, I'm not playing anymore. And now we're on Generation 8. Like, literally Generation 8. But there's a problem. Generation 8, they decided they wouldn't have all the Pokemon in Generation 8. I was going to buy it for my Switch, and then I realized my favorite Pokemon, which is the only Pokemon I go through all of these games with, is completely missing from this game. Like, just completely missing, right? And I'm like, man, that's my favorite. Like, without this Pokemon, it's not Pokemon to me. I literally would transfer an egg of this Pokemon to my Game Boy games so that I could play through the game with this Pokemon. You know, that's what I did. That's how I played it. It was always with this one. So since it's not in the new game, I didn't know what to do until, and I know this is what I spent my weekend on, and this sucks so much. I found out about this Pokemon Ribbon Master thing. I don't know if this is interesting to anyone. It's probably not. I'm sorry I'm rambling. I found this Pokemon Ribbon Master thing where your goal is to get as many ribbons on a Pokemon as possible. So, like, the only way to do this is to start out with your Pokemon on the GameCube. Get some ribbons there, transfer it to the Game Boy Advance, get some ribbons there, transfer that to the DS, get some ribbons there, transfer it to the 3DS, and then transfer it to Pokemon Bank, and then Pokemon Home, and then Pokemon Sword and Shield. It's a pain in the butt, takes forever to do. Kind of want to do it, just because, I don't know, like, it's the only way I can continue playing with my favorite Pokemon, and I like it a lot, so I don't know, I was thinking about it. As a waste of time, because I totally have time to waste. I don't know if this is worth talking about or not. Hey, Esden, how are you? Thanks so much for coming in. How's your stream, man? I hope you're doing super well. As we're rambling about, but I don't even know why I brought Pokemon in. Something happened. I think I said, why not? And then I thought about the Pokemon why not, and it just kind of came in. But yeah, Esden, how's your stream, man? I hope it went okay. For those of you who might have just been coming in and you don't know my stream too well, hello, I'm Simuleos. We're currently working on a project known as the Arcane Algorithm Archive. This is it's a book, an online educational resource where we teach you guys about algorithms, like, for example, Gaussian elimination. And what we do is we allow you to change, you know, whatever language you feel like, you know, you learn best in. So, like, here's, you know, Gaussian elimination, finding the maximum element in Java, for example, for that particular method. So yeah, that's kind of the point. It all kind of bleeds together with Twitch and the Algorithm Archive and my YouTube channel, which I think you can find here. YouTube? No, I think it's YouTube. Never mind, I did it twice. My bad. Anyway, right, so you can find my YouTube channel there. You can find the Algorithm Archive here, I believe. Yes. And you can find out a bunch of other stuff as well. Let's see. Nice. Always good to learn about things I have no clue about. Z-Man1942, thank you so much for following. Right, so today we're working on a new method known as domain coloring, or we're working on a new chapter for domain coloring here. Typically, the output for domain coloring looks something like this. And I'll explain what you're seeing just for the new people who just came in. So the idea is relatively straightforward, okay? Let's say you have some sort of function, which is f of x is equal to x squared, right? Typically, you plot that function like this, right? Some sort of 2D image with f of x on the y-axis and the x number line on the x-axis, right? Fair enough. However, if x is now in complex space, well, now you have a 2D input because you have an imaginary and real component for x, which means you also have a 2D output because you, again, have an imaginary and real component for the f of x, right? So what do? Well, we have to somehow plot it in 4 dimensions. Well, what are 4 easy dimensions to plot in? Well, we could do a 2D image. Here's 2D image. So we have imaginary and real of x here. But then we have our color bar where we could put, the real component of the output here and the imaginary component of the output here. So if we have a HSV color scheme, we can, or any 3-dimensional color scheme for that matter, RGB could work as well. We can actually do a 4-dimensional plot, the complex and imaginary of one input, the complex and imaginary of the output, just by coloring it appropriately. So here, for example, is a domain colored image for that, for f of x is equal to x squared. And we'll talk about what this means later on in stream. For now, what I'm trying to do is I'm trying to replicate this code to make it work for RGB color space. And though this looks remarkably different, the phase profile is the same. It's just a matter of getting all the other colors and stuff to work out for this. So while we're writing the chapter, we're starting with RGB, then we're moving to HSV, and then we're going to start talking about all the other things we can do to make the plot more understandable. And that's kind of the whole stream. So again, if you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know. This stream is about understanding algorithms and numerical methods, and this chapter in particular will blend its way into an upcoming chapter on FFTs and stuff like that. We do have the chapter for FFTs up. It's just horrendous right now. It needs a lot of updating. But yeah, Esden, I don't think you said how your stream was. I think you just came in. But yeah, if you have any questions, or yeah. How's your stream? How's everything going? Can you hack it? It'd be faster. I've read about someone who hacked a Tamagotchi. I don't think you can hack Pokemon. But no, I mean, it's not about hacking Pokemon. The truth is, like, so we were just talking about Pokemon when you raided. I don't know why. I just got on a tangent and I was just talking about it. But yeah, I always kind of like Digimon over Pokemon. Like, the games are always more fun, in my opinion. But Pokemon is more popular, It went very well. Thanks. Got some progress on the Glasgow Digital Interface Explorer. Dude, super cool. Yeah, great. Getting closer to getting the next prototype done. Super cool, man. Yeah, keep up the great work. Big fan. Okay, I tend to lurk in everyone's streams. Like, I don't know why. I never say anything in anyone's stream because I'm always afraid. I'm always afraid someone's going to call me out. They're going to be like, hey, this guy also streams. And, like, I don't want that. I just want to chat. I just want to, like, chill. So I don't tend to talk too much in other people's streams, but I tend to watch a lot. But yeah, great stuff, man. Keep up the good work. Okay, so let's go into VI domain coloring RGB here. And let's just try to get this to work. There's a lot of stuff to be done, and admittedly, NuPlot is not the most easy to understand scripting language, but we're just gonna go with it. So right now, it all comes down to this plot command down here, which is a 3D plotting command. What we're doing is we're saying we're going to plot ++, which is going to be some number line that we put into the system using the first dimension and the second dimension. Again, this is just your imaginary and your real input. And then we're going to color the next line. And how are we going to color it based on X and Y inputs? Well, we're going to find the angle, which is going to give us our theta of the real and imaginary components of our function. And then we're going to do, let's see, absolute value of f of x times 256. Yes, so I think we just want to do, instead of absolute value of f of this, I think we just want that. So let's write that, and we're going to do right quit. And now let's try new plot on that guy. So let's do GNU plot. What am I looking for here? Domain coloring rgb.gp. And we should get a new image that should look pretty cool. Could you, instead of color, put little subgraphs at each point like an arrow vector? Yes, you could, but there's a question of what directionality means in that case. you know? So I don't really know. I'd have to think, ooh, that looks dramatically different than what I was expecting. Does this actually make sense is my question. So let's just look at our two plots here. Here's one plot. Okay, and here's our other plot. So let's do that and that. Okay, so I'm arguing that these plots are the same thing. That's my argument. How am I making that argument? It is because our function here is coloring via RGB. So I have to make sense of this, and I have no idea how. Okay, well, we'll mess around with this a bit. Hey, Prats, how are you? Let me make them up here, so because we're gonna be looking at these images for a bit while I try to figure them out. Okay, so here are the two images, and these are the same function. They're both f of x is equal to x squared. We're just representing them in different ways. What I'm gonna do right now is I'm actually going to. Oh, okay. So so we're plotting two different things. In RGB space, we're plotting the red component is going to be changing based on the red component is going to be changing based on the phase, which goes from 0 to 2 pi, and the blue component will be changing based on f of x squared. Just came from Wolfram's stream. How's he doing, man? Wolfram is such an intelligent person. I don't know. He's kind of like, I'm amazed that he streams on Twitch. I'm flat out amazed that he streams on Twitch. So we're doing f of z of. So do I need to scale that? Dr. Young's lab. Hey, how are you, man? Thank you so much for the raid. I hope you're doing well. What are you up to, man? How have you been? How's your stream? Virtual assistant. Hey guys, how are you? Right, so actually we did just get another raid. So let me, so for those of you who are here, or, how am I going to do this? So, first of all, Dr. Young's lab, hey, how are you? We just got done some basics of chemistry. Dude, super cool. I think we've hopped onto your stream a few times. I don't know if we've officially rated you, but I think I do remember your stream a bit. What particularly were you working on? Basics of chemistry. So that would be like, what kind of basics of chemistry? Is this like high school basics, or are you talking organic chemistry level? Captain Sausages, thanks for following. Okay, so let's start at the start. So hello, my name is Simuleos. In particular, my name is. Okay, let me try this again. I'm super tired today, and I'm not able to speak. I'm Dr. James Schloss. I have recently got my PhD from the Okinawa Institute of Science and Technology. I work at MIT on climate simulations, and right now we're working on a side project of mine known as the Arcane Algorithm Archive. This is a book, an online educational resource for algorithms of all kinds. So here, for example, is Gaussian elimination. Here's the method, how it works, all that kind of stuff. And then what's nice is you can actually change between all the languages in the book. So if you want to learn Gaussian elimination in C, Julia, Python, whatever, it's all available here. And that's kind of the idea of the book. Today, we're working on a new chapter for domain coloring, which is a way for us to represent a four-dimensional plot. How does this work? Well, I'm glad you asked. Give me just a second here. So let's say we're plotting a normal function. You would normally plot that function like f of x is equal to x squared in a typical box like this. So your x-axis is x and your y-axis is the f of x, and you get your typical parabola in here. But let's say that your x component is actually complex. Well, in that case, you have a two-dimensional input, the imaginary real component, and also two-dimensional output. So this is actually a four-dimensional space, right? How are we going to plot that? Well, we can do a two-dimensional image, 2D image, and then we have an imaginary component and a real component here on the x and y axes for our input variable. And then our output variable, we do the imaginary on the saturation and the real on the hue of some sort of three-dimensional color space, right? So what I'm working on now is I'm working on getting a three-dimensional color space that is not HSV, working as we work through our algorithm archive chapter. But yeah, this is the idea. It will create plots that look like this, which are kind of cool, colorful plots describing what a function is in two-dimensional complex space, which is kind of cool. And so we're working on making this image in different ways to make it just cleaner and easier to understand from an intuitive level as we're writing this next chapter. Revenge, thank you so much for following. Really appreciate it. Mechanisms of organic chemistry are the true devil. Yeah, didn't like organic chemistry when I took it in university. Let's see, Wolfram language, evil though. I don't know so much about the Wolfram language. You're doing fine. Looking at a very fundamental atoms periodic table, isotopes, ions. Yeah, super cool. So I worked on ultra cold atoms for my PhD, which is, it's not chemistry. It is definitely not chemistry, right? Nothing like chemistry. But yeah, so I used to work on a bunch of different BECs of, like rubidium 87 atoms and stuff like that. So I think it's really cool, all that kind of stuff. I just never really got into chemistry proper. I was always working on physics, It's all chemistry somewhere. Yeah, to some extent, right? I mean, yeah, I guess. A lot of people say it's all physics or it's all math. It just depends on what's what or who's saying it. Dr. Young's lab is fun and educational. Yep, super cool. Math concepts are required to understand the book. It depends on what chapters you're reading. Like, for example, if you're looking at the plotting chapter, there's no math to understand the plotting chapter. We do have a somewhat heavier focus on numerical methods and stuff like that, because it's kind of my expertise, and also it's the Arcane algorithm archive, so it tends to be that these more numerical methods that require stronger mathematical understandings aren't really super well described in other books, in my opinion. So this is kind of, a way to remedy that. So, for example, we have the split operator method for solving the nonlinear Schrodinger equation and stuff like that, which is really cool. It gives you like a good algorithm to solve quantum systems with, all that kind of stuff. So here's, a single atom sloshing about in a harmonic oscillator trap. Let's see. There are some similarities with MATLAB. Yeah, I don't know. I don't really like MATLAB too much. Let's see. I've done once visualization with many little graphs. Yeah, let me take it. Oh, I think you showed me this before. What's in the V? The V as in, oh, yeah. This is, yep. Yeah, I've seen something like this before. Yeah, cool. Let's see. Don't want to disturb, but should clicking the Twitter button on the article pre-create a tweet with the article name? Like, link to it on, actually, let me see. What does it do? That's my question, because I don't think anyone clicks on the Twitter button. So what does it actually do? So if we go here and we move up to the top and I click the Twitter button, this does nothing. It just opens up Twitter. You're right. It probably should do that. I don't know how to get it to do that, but that's another issue. Definitely bring that up. Thanks for doing that. If you could create a PR, that would be great. If you create an issue, that would also be useful. Because I don't really know all the JavaScript stuff. Like, I've had to ask people to help me out there. Let's see. How do you do the fourth dimension? That's interesting. Yeah, so the 4D stuff, again, it's just going to be X real on the X-axis, X imaginary on the Y-axis, complex phase in the color bar, and then like the saturation of that phase for the like real values or whatever magnitude. I could really have used this in grad school. We did a bunch of FFTs on quantum beats and photoexcited molecules. Yeah, so I am doing my best to update the FFT chapter. It's not particularly good right now. There's a lot of work that needs to be done there. Let's see, 3D is equal to XYZ, 4D is equal to... Oh, right. So I actually have a video on 4D stuff that I get a lot of comments on. So let me go to youtube.com/user/LEIOS. The easiest way to understand 4D outside of... It's actually my most popular upload. It's got 3,051,000 views or something like that. But here's that video. Let me share it and then do copy. And then I should be able... Oh, no, I don't want to do it. Start... No. Whatever. That should work. Nope. That should work, I think. Yeah, so the easiest way to understand 4D, for spatial dimensions, journal new page before, is by taking your matrix, which will be X, Y, Z, and some fourth dimension W, right? And projecting it onto 3D by multiplying it by a 4x3 matrix. So I don't know, it doesn't matter, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. 1 second. Let me get that 0 aligned. So if you multiply by a 4 by 3 matrix, this will allow you to project onto 3D so you can do the plotting. Let's see. Holy moly, that's really cool. Seems to casually explain some really complicated stuff. Right, yeah, that's kind of the idea on the original plot. Let's see. FFT is overpowered. It definitely is. You could use T as the 4th dimension if you want. Yeah, that's fine. It's definitely modulating the value because it's broken currently. Yes. So, yeah. I could create a PR. What's driving the site? I saw some LaTeX-y stuff. It's actually mainly Markdown, and we're using something called Gitbook underneath that translates the Markdown to HTML. I'm not going to say that's my favorite way to do it. We actually have a lot of problems with Gitbook, and we're trying to move away from it right now. But that's how it's done right now. Let's see. The argument for the complex number is x, y, and the complex outcome is a hue and brightness. Right. Let's see. Tim's... is it Timonsky? Timonsky? Thank you so much for following. Really appreciate it. I'm currently playing with MD Book. Always interesting in ways of writing together. Yep. All right, guys. Gotta head out. See you, Dr. Young. Thank you so much for coming in. Right. So as far as MD Book is concerned, there's one thing that we couldn't figure out how to do in MD Book. So if you know how to do it, that's great. We couldn't figure out how to get these code blocks to update like this in MD Book. Currently, we can't figure out how to do it in Python either, so we're trying to figure that out for the next bit. Virtual Assistant, thank you so much for following. Really appreciate it. It's hue and value. Actually, you might be right. I might be using hue and value instead of hue and saturation. That might be what I'm doing. My bad. We can play around with it in a bit. Okay. So let's try to get this RGB stuff working. I think I need to scale this by divided by 4. So let's see what happens if I do that. So we're going to go here, and we're going to run GNU plot and see what this does. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I'm going to do my best to answer them as soon as I see them in chat. I'm not going to guarantee I can answer them perfectly, but I will answer them to the best of my abilities. Again, I am a bit tired today, so I might, I don't know, say something really dumb. That looks identical to the last plot. Now, is that what we want to see? I have no freaking idea. So let's try to describe what's happening here. Okay. So, the function we're plotting here is going to be f of x is going to be equal to x. Oh, let's try that again. X squared. Okay? And then we're dividing by 4, just because our grid is of size 2 by 2. So the highest value we could possibly get... Oh, that's not true, is it? Ah, okay. No, we need to scale by something slightly different. It should be divided by, not 4, I think it should be 2 squared by 2 squared. So the number line, the highest value you could possibly get is 4. But no, it's not 4, it's 2 by 2. It's the square root of 2 squared plus 2 squared. It's 8, isn't it? I have no idea anymore. Square root of 2 times 2. We have a box here. This is 2, this is 2, which means this line from here to here is going to be 2 by 2. So the hypotenuse is going to be, r is going to be equal to x squared plus y squared square root. So shouldn't it be, am I wrong here? Shouldn't it be x squared plus y squared? Which is going to be equal to 8. Well, it's square root of 8, right? But because we're looking for r squared, it's just going to be 8. Am I doing math wrong? I'm going to say it's 8. Let's try this again. I must be doing math wrong. Square root of 2 times 4. Let me think. Well, anyway, let's just see what this looks like. It doesn't really matter. We're going to get the same behavior no matter what we do. Okay, so I'm going to try to explain this plot, what it is that we're looking at, and we're going to try to figure that out. Okay, in fact, before doing that, let me change our function that we're plotting here just to be f of z. So yank paste here, and it's just going to be f is equal to x. So literally what we're plotting here is just f of x is equal to x. And that didn't work because... Yep. That's why it didn't work. Cool. Someone did domain coloring on Shader Toy with an animation of 20 different in one script. Yep. Let's take a look at that. I mean, the issue with it is, like, we're trying to, like, so we're teaching domain coloring, right? So, like, it's one of those things that it is, like, so we want to show people how to understand this code, essentially, is what we're trying to do, right? So I'm more interested in, like, the intuitive understanding, because we can make these images right now. Like, there's no issue. We can definitely make these images if we want. But yeah, the point of what we're doing right now is to understand, like, different color spaces and things like that. So pretty short code as well. Yeah, it's super quick. It's not very hard to do. Square root of 2 times 4 is equal to 2.8. Why are you doing square root of 2 times 4? I don't understand. Mirage out.png. See, this is remarkably different. Oh, yeah, this is obviously different. Yeah, okay. So let me think. What are we actually looking at here? We are looking at... it must be integer casting somehow, isn't it? Is it? Let's see. What if we just do... Right, I don't understand. So virtual assistant, I don't understand why, yeah, I don't understand. I'm so sorry. So let's do GNU plot, Mirage. This is a heart plot as well. Yeah, probably. I'm just bad at doing plots. You need to use complex numbers. Oh, you know what? Yeah. Yeah, okay, you're right. You do need to use complex numbers. No, wait, no. No, you don't. Okay, this is not the plot I was expecting. This is remarkably different than the plot I was expecting. So the output, RGB. So what we're doing here is we have RGB. I was expecting to see... So what happens if I just... I'm going to modify this so we have no green. Try that again. GNU plot, Mirage. And we're just going to try to figure this one out. I'm sorry I'm so scattered today, guys. I am trying to stay focused, but I'm just all over the place today. For some reason, don't fully understand. I'm just everywhere. Probably because today was just like a lot of meetings. Okay, that looks identical to what the previous image looked like, which isn't great because that's not what I was expecting to see. So why is... f of z of... Okay. If I put an absolute value here. Okay, because the function becomes negative under x, which it doesn't know what to do with. So it just kind of, I guess, rails that up to all blue or something? I'm not really sure. Maybe that's what it's doing. Okay, yeah, this is what I was expecting to see. Okay, nice. So what we see here is a 2pi phase winding. That is to say, can we do this in 2 colors, or does it have to be 3 colors? It has to be 2 independent colors. Right, so we could do it in a 3 color space, at best. But we could do... It has to be 3 independent colors. So, like, in this case, we have black as the lack of red, and black as the lack of blue. In fact, like, let's do... I'm so sorry. What am I going to do here? So what if I do 256 here? What happens there? Mirage? So that should make it so white. I'm just bad. Why am I so bad at this? So this should make it so the background color is green. This is super complicated, and I'm really bad at explaining what I'm doing exactly. No, this is the same plot as we had before. Okay, so let's change this to z squared again, and let's see what that does. Yep, so z squared. Let's do GNU plot mirage. I'm enjoying this. Well, thanks for being here. I'm sorry I'm so out of it today. We'll just do it. We're just gonna keep going. Yeah, some days I'm in it, some days I'm out of it, and today's an out of it day, but that's okay. We're gonna make images and we're gonna just do stuff. Ah, that's the exact plot I wanted. Nice. Okay. So let me explain what's happening here. Because we're using an RGB color space, what we're seeing here is that we're seeing a 2 pi phase winding, right? So what this means is that we're doing z squared, which means our complex number is being multiplied by, you know, every individual point is like x squared or something like that. So what this does is it makes it so that our phase actually goes through a 4 pi phase winding instead of a 2 pi phase winding. So this strong discontinuity here is essentially where we're going from 0 to 2 pi, and then it flips back down to 0 to 2 pi. So that's kind of the idea, is going from 0 to 2 pi and 0 to 2 pi again. So if we do x cubed, what we'll see is a 3 pi phase winding, I believe. Unless I'm an idiot, in which case it might be a 4 pi phase winding. But I think it's a 3 pi phase winding. We'll see. Ah, I mean a 6 pi and an 8 pi. I think this will be a 6 pi phase winding. Would it be useful to use the identity function to explain the concept? Right, so the identity function of f of z is equal to z. Yeah, that could be useful. I think maybe that's what we should do. Yes, there we go. Look at that nice plot. Now, here's where things get really weird, and I need to think about it. What is going on with these things? So what is that saying? We are going from... Okay, so let's do something weird here. So what we're going to do is we are not going to divide by 8 anymore. Okay, so we're going to run GNU plot, then mirage. Screwed up. Typed in the wrong thing. But you know, one day I'll type in the right thing. That day's not today, but you know, eventually. I think you're right, actually. I think we shouldn't be plotting x squared. I think we should just be plotting f of x equals x. Would you consider yourself more of a mathematician or a programmer? Perfect. Look at that. That's a good question. I don't actually have a good answer for that question either. I suppose in some sense, I'm not trained as a mathematician, nor am I trained as a programmer, right? But I have a PhD in, you know, computational physics, so I guess that says that I'm more of a programmer than I am a mathematician, right? That said, all of my interests are in like mathy algorithms or something like that. So I fit pretty nicely in like computer science theory or something like that. I fit very well into applied mathematics as well. So yeah, something like that I think is where I fit. Let me zoom into this image and let's just start dissecting it. So if we zoom really far in here, it's getting really trippy. If we zoom really far in here, just ignore the blue out in the corners. This is what we would expect if we were plotting only the phase, right? Because if we're plotting only the phase, we should see, you know, a 4 pi or a 6 pi phase winding where we go from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Now, as we go out, we start to see some blue. Are you going to zoom out or are you just going to... Oh, So as we go out, let's see, we start to see some blue, which is to be expected. And it looks like, I can't quite tell if the phase is doing something weird or if the... So let's just remove this absolute value of f. Let's remove the blue from the function entirely. Yank, paste, and we're going to comment this out. So we're just going to make it all blue, and we're just not going to worry about it. And let's see what this does. Again, these numbers are kind of weird. There's a lot of stuff that we need to work on there. So a tan of y2 gives you an angle, but with a quadrant, what happens if it's just a tan? Oh, that'll just give you, yeah. So you could also do it with just a tan if you wanted to. You just have to like add 2 pi to y. There's like a loop that you can do. Yeah, so this is exactly what we expected to see. So that's just all red without any blue. Okay, so now when we put on the blue, and we color it based on the absolute value of f of z of x and y. I think the reason that we see... Oh, gosh darn it, I dropped something. Okay, so here's what I'm going to do. I'm going to plot this one more time. And let me try to explain where this stuff appears. It's explained in the complex area, which becomes muddled when translated to simple language. I would like... Okay, so let me explain why I don't know if I necessarily... Okay, well, let's just think about it. So let's do mirage of out.png. Here. So here we have this guy changing. So if we just take the x-axis, right, where everything is real, we still see this color bar going from basically 0 blue to 1 unit of blue. And it goes from 0 blue again to 1 unit of blue, and then 0 blue and then again to 1 unit of blue. I think what's actually happening here is that we are... we're using too much blue. Like, the colors are... Yeah, let me see what happens if I do 255 instead of 256. Change this to a 5. And let's do GNU plot mirage. I think we're actually just like... We're going from 0 to 255. And then when we hit 256, it's 0 again. So I think that's what's happening. I think it's just going up and then dropping back down, then going up and then dropping back down. Because I think the maximum number that we can put in there... Yep, so now this is all pink and... Yep. Yep. Here we have a nice and pretty plot where it's all blue and pink. So I think all we're doing is we're railing against the top. So we're going from 0 to 255, and that's when it's at the maximum blue. And then at 256, it drops back down. So I don't know why I decided I would put 256 in for green. Well, I don't know why I'm multiplying everything by 256 instead of 255, but it's what I'm doing. So let's modify all those so we're doing it by 255 instead of 256. Okay, change that to a 5 and change... Oh no, that's correct. And change it. FFX is 255. Yeah, I don't know what I was doing. I don't know why I was multiplying by 256. I think I just liked 256 for some reason, and I just wasn't thinking about it. BKM_Dota, thank you so much for following. Really appreciate it. So, let's see what this one looks like. It should just be all white, I think, with like little red specks, I guess. No, not quite, but it's okay. I don't really care too much. Okay. So that means we have, I'm going to set this equal to 0. It's the same as setting it to 256. And we're going to color this based on the absolute value of f of z. And I believe I have to multiply that by 255. Okay? So we're going to do GNU plot. F of... What am I doing? Absolute value of f of... Can I just do f of x of y? What did I do before? Oh no. What did I plug in before this to get this to work out? I deleted that line because I'm... Oh, no, that was... No, yeah, that was the line I deleted. Let's see what we have in the other file. So vi domain coloring.gp, move down here. I was reading in value of x, absolute value of f of z of x and y. I see. Okay, that's z of x and y. This is a dumb way to do it, but it's what I did, so you guys are just going to have to deal with it. New plot, then mirage. Yeah, I think you're right. That's what I did, because z is... It's f of z of x of y. Thanks for that, BKM Dota. Okay, let me get some water. It looks like we almost have our RGB plot created, but I think... Who said it? Someone said they want to use the identity plot, and I think that's actually best to do that as well. 0, 0 to FF is 256 values, including 0. So I think all I need to do is actually scale this appropriately, so that if we get up here to the upper left-hand corner, we... we know that that upper left-hand corner is 8. No, square root of 8 times 3. Square root of 8 raised to the third? Yep, that's what I'm doing. That's my color bar. I don't even know what that is, but that's the value it is. So let's do GNU plot Mirage, and this will make it so we don't have the weird cutoff thing. It doesn't go to 255 anymore. It just means that, you know, when we get to the upper right-hand corner of the plot, that value is set to be the maximum value. Nope, I did it wrong. Also, what's going on here? What's up with all this stuff? What did I do? I screwed everything up. That's what I did. What am I looking at? How do we have green in the plot at all? Didn't I set green to be 0? I did. I set green to be 0. So where's the green coming in? What? I'm kind of lost. Oh well. Let's just see what happens. Welcome to Simuleos, the stream where we attempted to do stuff, or attempted to get work done, and we end up getting none of it done because we can't even figure out how to plot things correctly. It's the same plot. So where's the green coming in? I'm setting it R, or is there no green coming in? And maybe it's the lack of the other colors. Or there's some sort of floating point precision error? Maybe? What is square root of 8 times 3? So let's do square root of 8 raised to the third. And this is 22. You have a green? What do I have for green? Stuart rules. I'm lost. I set green. So you got 4 values. No, I only have 3. Yep. So I have the angle, which is the complex phase, times 255, 256, and then absolute value of this. Yeah, no, I only have 3. I mean, the commas are a bit weird, so it is kind of hard to see. But, yeah. So, like, this is all one argument. The angle of this is all one argument. So, let's see, so that's gonna be 22. Oh, I'm multiplying, I should be dividing. I see. I gotcha. Now I understand. Okay, so we're gonna do GNU plot Mirage. This should be the plot I was looking for. Yeah, this is definitely the plot I was looking for. Cool. Cool. I say definitely, and we haven't seen the plot yet, but this is like a, you know, a Simuleos guarantee that this is the plot we're looking for, and it is perfect. Look at that plot. Nice. Okay, that's what I wanted to see. Now, let me think about this. The minimum color space. Could we do this in black and white? No, because black and white is... Yeah, no, black and white wouldn't work here. It has to be a color space with 3 independent dimensions. Otherwise, it doesn't work. So it has to be 3 independent dimensions. Okay, cool. Also, if I say or do something that just doesn't make any sense, just, you know, let me know. I'm trying my best to explain everything as I go about it, but, you know, sometimes it's hard. So we're going to set this equal to 0, and let's go back to the algorithm archive, and let's see what plot we're actually looking for here. So as an example, let's look at a very simple function. So I said, let's again look at the function f of z is equal to z squared. But actually, I think I agree with what someone said in chat. So let's look at the simplest function we can. So let's look at the simplest function we can. F of z is just equal to z. But in this case, z is within, you know, complex space. If we use an RGB color scheme where red represents theta and blue represents r, we'll say the magnitude of r. So what did I say before? I think where r is a complex oh, no. I set r as, yep, that should work. Okay, we can generate the following image. So I think we're going to do the regular image first. So let's just write the rest of this. So here we have insert image. as a note here, there is a clear phase discontinuity. Where is that phase discontinuity? I think it's along the, let me see. Okay, so I want to modify this so it's now square root of 8 there. Now we're going to run GNU plot. Run GNU plot and then Mirage. Okay, so there should be a phase discontinuity going right along the vertical axis. And that's what we expect, right? So it's going from black, which is where we have a phase of 0 pi, to red, which is 2 pi. Yeah, so let me go ahead and write that down, and then we'll fix the plot so it actually has the appropriate color on the color bar. See, as a note here, there's a clear phase discontinuity along the vertical axis. That is to say that the complex phase wraps around the origin, ranging from 0, which we'll say black, to 2 pi, which is going to be red. Okay. Oh, sorry about that. I hit the microphone. In addition, the edges of the plot are blue. And this is because the function value increases linearly as we move from the origin. If we instead look at the function the same function as before, one second, f of z is going to be equal to z squared, we will see a similar plot. We can generate, let's see, so we can generate a similar plot. What do I want to say here? So we can generate a similar plot here, and I'm going to insert in the image. Okay. So this is where things get a little bit weird. I don't know how to do 2 color bars in new plot. Is that even possible? Can we do that? Let's see. New plot boxes with different color bars. Nope. Images for 2 color images. Let's see, surely there's an image here. I would like 2 different color bars on the same plot. Looks like we can do it. Temperature here. Good. Okay, that's kind of what I'm looking for. Let's see. So we have set palette for the X ticks. Set palette max color, so set color bar ticks, Z step. I mean, we can just create our own color bar and twice over. So we can have one red color bar, one blue color bar, and we can just do like image manipulation here to get the image that we want. Like we could do that. Yeah, we could definitely do that. I just don't know if that's the best way to do it, or if that's something we actually want to do, or if we should do this a different way, you know? So there should be a way in new plot to create 2 color bars, right? Like how hard, it can't be that hard. I just don't think it's a typical case. Like people don't typically do 2 color bars in a single plot. So we might have to draw our own box with shading or something. This is something I have to look at. It is a downside for using new plot for this. Like probably I should be using any like normal plotter, but I'm not, because I'm just using new plot and that's what we're doing. Which is, it's kind of interesting, is like I've learned a lot about new plot with this, like, and I think it's kind of cool. So was this all done in the same, let me take a look at this demo script. So this looks like this was all done in its own little thing. So do 2 plots maybe? Well, let me see. So we have set palette RGB, set title traditional here, and then we split G of X. Okay, so it looks like what's G of X is equal to X. this is super interesting. Okay, so the idea here is we're going to create a two-dimensional plot that's going to be g of y is equal to y. Oh, this is weird. Okay, but this is totally doable. But we have to do it kind of manually. So we're going to draw our own boxes. Weird. Here's a minimal script to generate that plot. That wasn't the plot I was looking for. But yeah, so we can manually just draw our own color bars. So that's what we're going to do. So we're just going to manually draw our own color bars. So we have one that's already set to be what we expect it to be. So let's go ahead and get that done. So what do we have here? We have phase angle there and our color bar. So I guess, where's our palette defined? I don't think we did. I think we're going to have to set our palette defined. Somewhere in here. So here's the color bar. So let's do set palette. How do you spell palette? Palette defined? Oh gosh, I just did this yesterday and I don't remember what it looks like. Let's go here, vi domain coloring.gp palette. Here we are. Set palette defined. Yeah, that's what I'm looking for. Set palette defined, and it should be red. So it's going to be actually 0, 0, 0, 1. Yep, and then 1, 0, 0, 1. So that should give us at least one color bar down. So let's go here. Let's run GNU plot Mirage. Thanks for that, virtual assistant. And so this should give us our red color bar for the phase angle. And then we have to do the same thing for our complex magnitude. And while I'm at it, I do actually need to draw down... the phase angle looks all blue, doesn't it? Crap. That wasn't what I was expecting. Okay. So then... set palette defined new plot. Let's see what that is. So, I think I have this in my chapter over here. So let's do plotting, and let's do palette. So we have 0, 0, 0, 1. Oh. That's easy. Is that going to do it? Ha! Oh man, that totally worked. I think. Let's see what it looks like. That's super exciting if that works, because that's super easy. I don't have to think about that anymore. But I do need to think about a new... okay. I'm almost done. There's some other things I have to think about here. Also, I need to figure out if this is going to work when I do this in LaTeX or not. So Mirage. Okay. The phase angle is upside down, because it's starting at red. So let's change this from black to red. So this is going to be black. And it's going to go to red. Okay, so that gives us that color bar that we want. So let's new plot Mirage. I'm now going to set the X and Y labels to be what they're supposed to be. So we have phase angle 0 to 2 pi. That's correct. But now I need to set the X and Y. Set the X and Y labels as well, which I think I did for a previous plot. So let's take a look at that. So we're going to go into vi, I think z2.gp. And I did, yes, X and Y labels. So let's go ahead and set those. Up here, I think, is where I'll do it. So set X label, and this is going to be equal to, let me think. So I'm going to set X label equal to, and I believe it is going to be, I think I can just do real. And then I want to do this, X, that, and then set Y label equal to imaginary. Okay, so this should be what we need. Now all we have to do is figure out how to get that last color bar on the image, which is what I'm kind of dreading doing that, but we're going to get it done. So let's take a look at this one more time, just to make sure we have it all ready to go. So let's do GNU plot Mirage, and then we just have to get that last color bar in. And then we should have a plot ready to go for the algorithm archive after a matter of, what, 45 minutes? Oh, no, it's been longer than 45 minutes. It's like an hour, 15 minutes. But that's okay. It takes time. It's cool. Everything's fine. Let me get some water. Right, so let's do Mirage. Okay, cool. And we're going to change this to LaTeX mode in a bit. It's just since we're not in LaTeX mode, that doesn't look right. And also, since we are going to do this into LaTeX mode, probably should modify this so it goes from 0 to 2 pi. Okay. That was not the right ending there, so let's do this. Okay, so now we got to figure out how to make that other color bar. So first, let's go ahead and create set palette defined here. So that's going to be the final palette. So here we're going to do set palette defined. Oh, you know what? Maybe they didn't have... Maybe these aren't all in the same plot. So by the color becoming a domain, does that mean that the color is like an axis? I'm trying to get my head around how the color model works. Yeah, so what we have here is... that's exactly how it works, right? So we have 4 axes. We have X and Y, right? And then we have 3 axes in color space. H, S, and V, or R, G, and B, which is what we're using here. So R counts as one axis, G counts as another axis. But we have to be kind of careful about it, right? So let's do journal new page before. So our axes that we're using here are X and Y, and we're assigning this one to be equal to the real of X, and this one equal to the imaginary of X. Right, and then we have 3 colors, H, S, and V, or R, G, and B. And this is going to be equal to, see Trash Talk, thanks for coming in. This is going to be equal to, let's say, the phase. So this is going to be equal to theta, for example, and this is going to be equal to R, where what we've done is we have defined Z as equal to R, E to the I theta. Which is, you know, a typical way to express complex numbers. And then we have read this into the function, right? So in the end, the theta, the phase, goes up into R space, and the magnitude goes into B space in here. And now you might say we have an open axis in here, but that's the part that's actually kind of tricky, because let's say, you know, because we only really have 2 axes here. We have theta and R to plot, right? Let's say we set this color to be white and this color to be black, right? That doesn't exactly work because white, well, black is the absence of white, right? So you can't just like increase this color, right? So what our actual space that we're working on here is our B space, but we also have black, right? So it's like it goes from black to red and black to blue, right? So it has 3 dimensions to it, in a way. Does this kind of make sense? Like the point is that you can't do this with just 2 colors. You need 2 colors and then something that signifies the absence of those 2 colors, right? Which in this case is black. So really we only needed 2 colors to do this, but I couldn't quite figure out how to do this in grayscale. I mean, I guess we could do the same thing where we have, you know. Yeah, it didn't quite work out in grayscale, I don't think. You need two separate dimensions. White is FFFF, black is equal to that. Yep. So we could definitely do that. But again, I just don't think you won't have all of the color space defined, right? So like if this was in grayscale, right? You could have this going from white to black. That's totally fine. But then it would start going to black around the edges, you know, which is kind of weird. In a way, I guess. So the fact that it goes to blue on the edges means you can still see this very clear phase discontinuity along the vertical line here. And that's kind of nice. I like that, actually. So that's how you can represent it better in that way. So you could clamp the colors very specifically to highlight relationships. Right. Yeah, so for example, if we did do this in... if we didn't do this in RGB space, but we did this in black-white space, you would get an image that I actually showed in my thesis. So let me bring that up really quick. So let me go to github.com, and it'll kind of explain why I'm not a big fan of those types of plot for showing. I'll show it. Let me go to thesis here. Here we are. And let me go to, should be finalthesis.pdf. And it's somewhere in here. It's a big file, but it's somewhere in here. It should be within the first. Here it is. So you get a plot that looks something like one of these plots in here. So view image. Make that a bit bigger. Here. So here, like, the phase discontinuity actually continues out through the edges in here. But you can't see it because the white obscures it. Now, again, this color bar has, you know, blue, white, red for the complex phase. But you can kind of see the problem, right? The phase discontinuity could, in principle, continue further, but we're obscuring that, right? So that's kind of what you'd see over there. Like, you can't see the full phase profile because of that. Now, I did this in my thesis because we were working with a different system where we actually didn't want to see anything but this region. So there was actually a reason to do that. But in general, there isn't. So it's, you know, you have to think about it. So that's what I was saying. That's exactly what you're saying. You could clamp the colors very specifically, like we did in that image, to show certain relationships. And that's exactly what we did. So, yeah, there are certain reasons to do that. Oh man, I do not know why I'm so tired. Did I just not sleep last night? Is that my issue? I just didn't. I have no idea what's going on. Okay. So what I've just realized is that I am what you might call an idiot. These were all separate plots. These were all definitely separate plots. So I think the only thing we can do is do some image manipulation to get this to work. I think that's the only thing we can do. It's going to be the easiest thing to do anyway. I don't know why I'm so hesitant to do it. So let's just do it. Let's just get it done and not worry about it. So let's go ahead and we're going to have to do it twice. So I'm going to go ahead and get the LaTeX script for this up and running, and then we will convert that to PDF. And then, okay, so this is going to be a bit of a weird set of actions, but it is what we're going to do. So let's move up here. And so we're going to do set output of file size, set terminal PNG Cairo. So I want to do yank paste, and we're going to do, oh, come on. What did we do for the previous ones? So we're going to go here and go into z2.gp, and let's do it. So we are going to dd comment this out, open this up on a new line, and actually I think I want to, hello? What, how did I get in that terminal? What is going on? Okay, lsstar.gp, and let's go into vi abz.gp. Yep, that's what we want, set terminal here. And we're gonna set the output to, change this to be an R again. Actually, let's just, well, whatever. I don't care anymore. Nothing matters. Let's go here. Paste that there. That's what I need in there. There. Okay, nice. And we're going to set this output to be, what am I calling it? I'm going to call it RGB.tech. Write this and quit there. Okay, get back to work. Let's see. So this is definitely not MATLAB. Like Sheen01, thanks so much for following. Really appreciate it. Mukashi mukashi aru tokoru ni simureas kita. Mukashi mukashi means a long time ago, right? Mukashi mukashi aru. So it's been a while. Toko aru tokoru ni tokoru. So you're saying it's been a while since you've been in one of my streams, right? So, hey, how are you, GDA? I hope you're having a wonderful day. I really need to learn more Japanese. My girlfriend's been getting on to me about that. Well, she hasn't been getting on to me, but, like, I can tell it's kind of bothering her. Actually, it's probably not bothering her at all, but it's bothering me that I don't know Japanese. PDF, LaTeX, domain coloring, RGB, sorry, GNU plot. Okay. Mukashi, mukashi, once upon a time. Oh, I totally misread that. Okay, let's translate this. I thought mukashi, mukashi, like, I know that's how you start. Oop. I know that's how you start, like, old stories and stuff. Once upon a time, Simuleos kita. Kita. Gomen. Kita. Okay. Fair enough. So we're gonna do PDF LaTeX, PDF LaTeX, and we're gonna do RGB.tech. And let's see what this looks like. Best case scenario, it looks pretty. Worst case scenario, it doesn't look pretty, which is still fine. Okay. It is taking a while, though. I did not expect it to take this long. Maybe because we're doing so many samples and ISO samples? I'm not sure. If it doesn't look good, we're going to have to worry about it. Don't beat yourself up about it. You learned more than did all those... Wait, don't beat yourself up about it. You've learned more than did all those years ago. Yeah, I mean, I am learning. It's just slow. So let's do ocular rgb.pdf. Whoa! Hello there, slow loading PDF. How are you today? That was super slow. This is crazy. Okay, whatever. Move out.pdf, rgb.pdf into rgb1.pdf. Okay, whatever. So now we're gonna set the let's see, phase angle. Oh, I need to redo this, don't I? I should probably redo this so that this is just theta. Something like that, I believe. And let's change the ISO samples to be... We could probably do 1000 by 1000. Right? Right? Okay, so let's see what do we have here. We're going to run GNU plot, PDF, ocular, and see what it looks like. Best case scenario, it looks pretty. It's not going to happen, but it could. You know, one day. Okay. And this will be our first of these two plots done. Still loaded slow. Let me zoom in to see how bad the resolution looks. I think it looks okay. Yeah, that looks pretty. I'm happy with that. Okay. So, but I missed it. How did I screw up on theta? Wait, what's wrong with that? Wait, let me take a look at that again. 2 pi. What is going on? Do I need to use single quotes or something like that? This is clearly not rendering correctly. And I don't remember what I did, but I remember we just had this issue a second ago. So let's do GNU plot, PDF, ocular. Yeah, this is not rendering correctly. So, hopefully this fixes it. I remember there's some weird thing about single quotes versus double quotes or something like that. And yes, that is the issue. So let's go ahead and make sure that our other system, our other quotes here using LaTeX are using single quotes. My word, I am unable to speak. Should this be just be a silent stream? Because at this point, like I can't, like my words are not coming out of my mouth as they should. I am so sorry. I'm just babbling. I'm hoping something is getting across, but man, I'm not doing a good job. Yeah, that looks good to me. Okay, so I think I can just run the last MV command. Okay, and let's do the same thing, and we're going to set palette to font. Okay, so let's do yank to yank, paste up here, comment that out, and then we're gonna go, wait a minute. Why am I going from 0 to 2 pi on the CV range here? Like, why am I going... This should be 0 to 2 times that, right? Okay, we're gonna have to do it one more time, but that's okay. Right, go over here, GNU plot, PDF, ocular. I personally think you're doing just fine. Oh man, I'm just tired. It's okay. It's okay. We'll get through it one step at a time. Okay, that image just kind of broke me a bit. What? What? So set palette defines 0. We changed the color bar range to go from 0 to to 2 times pi. And the image didn't change. So whatever, I'm just gonna make it so this is actually what it's supposed to be. It goes from 0 to 2 pi. Whatever, I don't really care. 2 times pi. Okay, so we're gonna do GNU plot, PDF, ocular. Let's see how this goes. So once this is done, we should be able to okay. I was expecting the 2 pi phase winding to occur along the x-axis, not the y-axis. You know? Like, why is it a vertical line going straight up and not... Am I just being dumb? Let me just figure this out. So Julia, a tan 2 of 0, 1. A tan of 0, 1 is going to be a phase of 0. So that should be black. But if we do a tan 2 of 1, 1 is 0 along x and 1. So what I'm looking for is 1 along x and 1. This should be... Oh. Okay, never mind. This is correct. This is fine. I'm just... For some reason, I'm not thinking straight. So that should be fine. So that's okay. So let's go ahead and run the last mv command. And let's get the other color bar label defined. So we're going to do yank and paste up here. And so it's going to be set palette defined, and it's going to go from black to blue. And in here, it's going to be complex magnitude. Was it? Did I do what type of phase angle? Okay. I forgot what types of capitalization I used before. This is just going to be R here. And it's going to go from 0 to... I guess it's going to be the square root of 8. I guess. Yeah, it has to be square root of 8. Okay. I don't know why I put a dash there. And then in here, we're actually going to remove the color bar ticks. And this should be the other plot we want. So we're going to do GNU plot, PDF, and then ocular. And I think this is the other plot we want. So we have the 2 color bars, and then we're just going to do some video editing here. Phase A, no, that's not right. Oh, did I forgot to comment this out. New plot, PDF, ocular. Okay. Now this should go from black to blue. I mean, in principle, it should go like... Why is it black? Ah, crap. What's going on here? Why is this not right? What's going on? It goes from black to blue, complex magnitude R, CB label, set palette define, black, blue. Did I forget to run GNU plot? Maybe. Let's see. PDF, ocular. Oh, I'm an idiot. I'm looking at the wrong plot. I'm looking at the one I just copied over. Okay, so we are going to do Mirage, ocular RGB.pdf, and that should be the right plot with the blue color bar, right? Complex magnitude R, fine. Okay, so I'm going to move RGB.pdf into RGB2.pdf. And now let's do the same thing, but this time for a, it's going to be 8 FZ squared. Right. And then we'll have these images ready. We can do some image editing and get the next 2 images ready for the algorithm archive. And I think that's where we'll close today's stream, because again, I'm kind of tired. So this is like another 10, 20 minutes of work. So this is going to be to just 8 now. Okay, looks good to me. So we'll do this. Theta. I think everything else should be fine. And actually, let me take a look at RGB2 again. Yep, that should be fine. I don't mind that too much. CB tick should still be off. So let's write this, go over here, and we're going to run GNU plot, PDF, ocular. And hopefully that, I'm looking at the wrong file again. That's okay. Give it a second. Complex magnitude of R, so RGB.pdf. What? Why is complex magnitude so close to... Yeah, why is it so close to the... Like... Okay, well, let's just change this so it's... What's the x-axis here? 1200. So now we're going to do GNU plot, PDF. Oh, this is going to be a pain, but that's okay. I think the plot should be the same size if we do this. We'll see. What did I just run? PDF, ocular. No, that's still close. So we're going to change this to 1000. And let's see, how do I give an offset? Let's see, offset color bar label, GNU plot. I'm in Japanese mode. Offset color bar label GNU plot. Okay, offset. So if we do offset 10 or something, how does that work? So it's going to be offset. Displacement can be controlled with the additional offset variable at 1, 2. So if I do offset 1, what does that do? Where are we? So where's the CV label? Song request pawn pawn pawn. That's a song. So let's do CV label here. And I think we want to do, oh, that's phase angle. Offset 10, 0. That should work. So we're going to do GNU plot, PDF, ocular. Yeah, hopefully this does what we want it to do. Cool. Cool. And yeah, I guess 10 was maybe too much. I don't know what the units are here. So let's do 0.1. I guess the units would be in centimeters? I'm not really sure. But 10 was way too much. It was off the plot. So, right, so that should be fine. That did nothing. So let's try 1. Okay. So we'll let this run, and then when that is done, we should be, hopefully our plot looks good after that. Yep, that looks great. Okay, so now we're going to move rgb.pdf into rgb4.pdf. Okay, so now we have to do the same thing, but this time for the complex phase. I think that's all we have to do. So let's do GNU plot, PDF, ocular. Hopefully we don't have to change the color bar location or the color bar label location again. But we'll see, We will see. Nope, that looks fine to me. Okay, cool. So now let's do some quick image manipulation. So we're going to move rgb.pdf to rgb3.pdf. And we're going to run GIMP for rgb.1.pdf. And I'm actually going to open up so we want to make it so the height here is 800. And import. Yep, that looks, oh no. That actually doesn't look that great. Try that again. So we're going to set this again to be 800. Let's see. Select all. I don't think we can fix that, so I think it is what it is. Oh well, it's probably fine. And now I'm going to open up a file browser, and I'm actually going to open up the next one. So we're going to do projects. Where am I? Algorithm archive, contents, domain coloring, code, new plot, and then we should have rgb2.pdf. Yep, import that. Cool. Okay, so here's what we have. I'm going to do tools, and I'm gonna make it slightly bigger, and then we go from there. Whatever, that's fine. Okay, so how do I do this? I need to make the, let's see, layer boundary size. So the height is 799. It should be 800. Well, anyway, the width, we're gonna set that equal to 1200. Okay, and resize that. And now let's do image. Let's see. View, image, guides. New guide by percent, horizontal 50, okay. Zoom out just a hair. Okay, and we're gonna move, oh yeah, complex magnitude. Okay. Yep, that didn't work. How do I make the layer bigger, but not like, you know, like the canvas bigger? So I guess it's canvas size that I'm looking for. Windows, let's see. Invert, auto, map, desaturate, tone, threshold, colorize, view. Is there a canvas size layer? There should be like a canvas size, isn't there? Select, view, image, canvas size. There we go. So I'm going to change this to 1200. Resize. And now I'm going to add image, guides, new guide by percent, horizontal, okay. And I'm going to move this over a bit. Actually, in fact, what I want to do is move that back to where it was before. And let's add in the other images as well. So we're going to do rgb3.pdf, import. No. So now we're going to move rgb3.pdf, import, and then we should have an rgb4.pdf, import. Okay, good. This is what I want. So now we're going to do image. Let's see. Where was it before? It was in canvas size. And then we want to change this to 1200. Okay, resize. And what am I looking for here? I want to cut some of this. So I want to cut that, I believe. That's what I want to cut. So we will do RGB4, Control X, and then again on RGB2, Control X. Okay, now we're going to do image, guides by percent, horizontal, okay. Select something else just because I feel like it, and move this guy right there or something. Sure, that seems fine. And then I need to do the same with RGB4. So they have to be at the same location, so we have the same size. Or flatten the image with background set to white. Okay, so let's move down. Just make sure that these guys are at the same pixels and everything, and then go from there. I don't usually like doing image manipulation this way. I just don't. It's not really my preferred thing to do. I think I want it to be maybe here, and then I want that to be there. So let's see. That looks pretty darn spot on. Like if we, that looks like it's on the exact same pixel. Nice. Okay, that's exactly what I want then. So let's just see what the images look like. So here we have the complex magnitude there. And I guess what I want to do is I want to crop this a bit. So let's do crop here and just crop it out to that space or something like that. So we will crop the image. Okay, this looks pretty good. So now we're going to do file, export as, and it's going to be RGB 2.png is what I'm going to call it. 2.png. Let's export that. Yes. Export. Okay. And now we're going to have to, I did it wrong. That's the one I want. File, export to RGB2.png. And now we want to do that one and that one closed. And now we're going to do file, export as RGB1.png. Export. Export. Okay, so let's put these images in their appropriate place. I'm going to discard those changes. I'm going to probably regret that though. Okay, so let's write and quit, and let's move code GNU plot RGB star PNG to resources. Okay. Now we're going to go into, again, the domain coloring script in here and just grab this image thing. Actually, this 84% one is probably the one I want. So then we're going to put that down where we have the image here. Open, paste there. And this is going to be rgb1.png. Where is it? rgb1.png. And now we're going to do yank3yank and paste it down here. Dang it. Yank3yank and paste it down here. Okay. DD there, and this should be RGB2. And now we should see if we open up the algorithm archive, it should have recompiled. Yeah, so it's recompiling now. And we should be able to see those two new images in the algorithm archive once it's done. And yeah, there we go. I think that looks pretty okay. Yeah, I think it looks pretty okay. Not going to sit here and pretend that these are the prettiest plots I've ever made. They're not. But as an introduction, I think it's okay. So we've still got a lot left to do. Obviously, we've got to introduce the HSV color space, all this kind of stuff. But that, I think, will be done next time. I'm honestly quite tired today, so I think that's going to be where we wrap up for today. Let's see. So let's see who's live and who we want to raid at the end of stream. We have Poku, who does a lot of art. Tim, I feel like we haven't raided Tim in a while, so maybe we do Tim after this. Yeah, let's do Tim. I think that's great, yeah. Or Go Pirate Software. No, let's do Tim. So let's raid Tim. Okay, so we're going to raid Tim, B-E-A-U-D-E-T. Cool. So thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. I will not be able to stream tomorrow due to some meetings I have tomorrow evening, but I will be back on Thursday evening where we will be streaming probably a bit of Klima work. I want to do some linear solver stuff in the early afternoon, and then in the late afternoon we'll work on algorithm archive stuff. In particular, I think I'll be working on my next video on iterative function systems. I hope to see you there. Again, guys, thanks for watching, and I'll see you next time. Bye, guys.